welcome in the room that keeps you from the drink. So after this talk, you can have a drink. I just noticed now that my dual screen is on, so let me check that quickly. Let's start with some piano. We're going to show you a few things. Welcome. What we're showing you is Melody Matrix. It's a little JavaFX project, and we're going to explain you what we're doing with it and maybe what I learned from it and maybe also what you can learn from it. So it's Melody Matrix. You can find it on the web as melodymatrix.rocks. It's both a desktop application and a website. And it's all running on the GVM. Of course, we are at the Java conference. It's a project by two people. The first one is Vik. He's my son. He's 14. I only have a few AI-generated slides because they all make mistakes. So 14, you write that as a 1 and a 5 according to ChatGPT. Vik is a full-stack musician. And that means that he plays different instruments, writes his own music. He dreams of becoming a hacker. I try to make that an ethical hacker. That sounds a bit better. And one important thing is at the right bottom, he wants to become rich. So he challenged me to write an app to get to that goal. Who am I? I'm Frank. I'm 50 years old. I'm a Java developer. According to ChatGPT, that's how I should look like. There are a few beards here in the room, but I don't have one. I have been doing Java development for over 15 years, and I am a big fan of JavaFX. We'll also see more about that in this presentation. I write blog posts, tutorials. I write for Fujay. Who knows Fujay? Friends for OpenJDK. Okay, good. Not enough people. We'll work on that. So that's a website, but we also come back to that. And I love Java and JavaFX, and that's what I want to talk about. Now, Java for the desktop. Who here is a Java developer? Okay, that's what I was expecting at the Java conference. Who is using Java for backend, Spring, stuff like that? That's also what I was expecting. But who is doing Java for desktop? Unfortunately, because Java it promised, and it still does, it's a promise since the beginning, Java is something you can run everywhere. And you can use it for everything. So we must be proud of JavaFX. It's that little niche project within OpenJDK that allows you to build user interfaces. And we must be proud of JFX because you can do amazing things with it. And now I need the scary music. Why are we using something which was developed for the web to build desktop applications? Why do we need gigabytes of memory to run something to chat with our colleagues? We can do better than that. We can do stuff with Java which is much better, which uses less resources and is easier to maintain, doesn't break every 6 months because there is a new framework which is better or should be better, or is just the talk of the town. We can do better with Java. So JFX is a project which lives within OpenJDK. That means that the sources are open. Everyone can check in the sources. Everyone can contribute, can file a bug, can solve a bug if you're brave enough to go into the code. And I'm from Belgium, and there is also a Belgian site on JavaFX. Gluon, which is a Belgian-based company, is one of the main maintainers of the JFX project. So together with Kevin Rushford from Oracle, you have Johan Vos from Gluon, and those two are the people who decide what gets into this project, what gets solved, what new features are included. So you can go to the Gluon HQ website, and you can download a runtime for JavaFX, because since, I think, Java 11 or 8, no, I don't know, it's not longer included within the OpenJDK project itself. But companies like Azul, where I work for, or others, have runtimes which have OpenJFX included, so you can run it with just one JDK. If you want to learn more about JavaFX, go to jfxcentral.com. It's a website about everything related to JavaFX, and of course it is created with JavaFX. Yes, JavaFX in the browser. There are ways to do that. So this whole application, this whole website is a Java application. It is available as a website. It's also available as a desktop application. You can now also have it on your iOS phone, and soon also on an Android phone. And it's all the same code. It's exactly the same code. It's only the build which is a bit different. So one code base for all, web, desktop, mobile. And if you have something that you have developed yourself in JavaFX, or you know someone, or you have a tutorial, you can add it to this website, because both the website and the data you find on this website are open source. So you can find them on GitHub, those two icons there on the top. By the way, all the links of this presentation, you can find them on my website. At the end, I will give you a QR code, and they are all listed here for all the people who want to try this out, all this magic. Because not many people are aware how many JavaFX is used, of how much it's used in companies, I'm doing these interviews. So every few weeks I publish an interview like this with people from companies or open source who are developing an application created with JavaFX. And because we are in the Netherlands, I want to highlight the one in the middle here with Ulas. It's from a Dutch banking institution, and they have JavaFX running as an internal tool, both for the development team as for the whole back office. So they're using Java and JavaFX very extensively there for different applications. But there are others. There are people who combine it with Kotlin, with Scala. So you can combine all these amazing technologies and build the application you need or want. Now, back to our pet project here, Melody Matrix, and how it all started. As I said, Vik wants to become rich. So he comes up with an idea every 5 minutes, I think. And one idea was, let's build, he's also a drum player, let's build a website where we combine movies, that's the wrong website, this one, where we combine all drum videos. So this is a website where you can filter, and you have all these movies. Which one should I show? This one? Oh, I'm not a bot. Okay, cannot show it. I can't have to go here. That's what we do. We use the YouTube plugin to include videos. Okay, doesn't want it to. Something strange with the network here. Anyhow, any idea how this website is created? Someone recognizes the styling and the framework? It's Java, and it's Vaadin. Vaadin is here. They have a booth. It's a great way to build user interfaces. They didn't intend it to be used for public websites. It's more for business websites and stuff like that. But again, we are using Java to build this. Now, that was the first project. And we have this. It's online. We don't earn any money of this. So we have a new ID. And this new ID is based on a YouTube channel from Vik, which is Pianoli. And you have all these amazing applications which already exist that generate something like this. So you start playing on your piano, and you can generate a movie like this. or vice versa. You can play yourself and create a movie like this, or have a MIDI file, or so you can make this. And this is actually made with a gaming engine, with C# and I always forget the name, Unity. So Unity, which is used in a lot of game applications, is actually used to create something like this. So the challenge I got from Vik is, can we create something like this? And as I always say, we can create everything with Java, so I had to start with it. And by the way, I'm beaten by my son. The left side is his YouTube channel, the right side is my Java channel, Music Beats Java. Maybe you can change this if you all follow me after this presentation, or follow him and then I'm beaten again, of course. So what are we going to use to create such an application? And I think everyone, who knows MIDI? It's a really well-known standard indeed. Okay, yeah, we're happy with that. So it's a musical instrument digital interface specification. A specification means that all the instruments that are MIDI compatible can cooperate. So you can connect several instruments and they know how to talk with each other. And it is an old standard. It's really old. And it is included in OpenJDK. So if you go look, for instance, in the sources of OpenJDK, you find within the package Java Desktop Share Classes, JavaFX Sound MIDI, there you find a whole list of classes which make Java MIDI compatible. You can read MIDI files, you can write them, you can communicate with the MIDI instrument. The only thing here is if you look at the dates, 7 years ago, 4 years ago, that also means this is stable. So the MIDI standard didn't change. The problem is I found an issue, and it's also very old. It's dating from 2015. If anyone can solve this for me, it's if you're on a Mac and you connect a new piano, it doesn't see it. So maybe this is the goal of my presentation today, that I find someone who can fix this for me. But so MIDI is something which is there, which is available, and we have a Java champion who is specialized in this. Geert Bevin, who is on the top left. He's a Belgian Java champion who moved to the States. Maybe he regrets it now after yesterday. But he is a software developer working for Moog. Moog makes synthesizers, and he makes software for that company. So he's in the embedded space, let's say. But he's also the creator of Build and some framework, a Spring alternative. So you can really know him from that kind of stuff. But he is also very experienced in MIDI because he's part of the foundation who specifies the new standards for MIDI. So there's a new standard upcoming. And I had a second guest in that Fujay podcast, Atsushi, and he created this Kotlin MIDI library. So why a Kotlin library on top of what is already in Java? It's because he wants to do more. So he has a multi-platform library. He creates different applications for different types of devices where he needs this MIDI communication. So I found this library. It has some extra features that are nice, so I wanted to implement that. And it's using Kotlin. Keep that in mind. Now, what is MIDI data? What is happening if he plays on the piano and something goes through this cable, which is just a USB connection between the piano and my computer? For every change that happens on the piano, I get 3 bytes of data. So it's very simple. The first one is a status byte. It tells me what type of event happened on the instrument. And the second, it's actually split in 2, and it also contains the channel. So you can connect up to 15 instruments in a chain. The idea is that you can exchange data between them. And then you have 2 data bytes. And what's in there depends on the status. For instance, if you have a note on or off, in the first data byte, it's the number of the note. And in the second one, it's how hard it's being pressed. And then you have some other types of data. We don't use them all in this kind of application, but they are there. By the way, that link on top really gives a lot of insights of how the MIDI standard, what it contains. Now, let's look what we can do with this MIDI data if we go back to the application. Let me close a few of these windows. Okay. So we already have this connection. You've seen it. I get data from the piano. So if I get one note, then you see that we have note is 54, the E4, which is number 64. You see that on the right. And 44 is how hard it's being pressed. Now, if he loses it again, we get a second event. So a key being pressed and released is 2 events, 3 bytes of data. Okay? Now, if we have the pedal, it's a controller message. And it's 0 if it's pressed. And now if you release it again, it's somewhere, there is some other data there. 64 was the first one. You see here? That's different. Okay? Now, if we play something, then you see that we have all these events bubbling in. Just simple data. It's the type of stuff we try to do at work. We have messages coming in from Kafka or another message bus. It's exactly the same thing which is happening here. So I have data flowing in, and then an event message, kind of internal events thing telling every UI, hey, I have a new MIDI data, and I can visualize it. Now, you see this layout UI is very basic, but it took me half an hour to add it to this program because I already had these MIDI events coming in. So visualizing data with Java and JavaFX is so easy. I have data binding between my table and my right side, so I can just go back and forth and see whatever he has done, clear the table. So everything is here, very easy, very to make. Okay? So that's how we can look at just the MIDI data. What is there? Who has a pet project? At least one pet project. Who is spending way too much time with it? Who made it way too complicated? That's where what people know it for developers. They make things too complicated. So let me give you an overview of what we are using in this thing. So for the matrix, for the user interface of the app, I already talked about it a bit, it's JavaFX. For the MIDI, I'm using that KT MIDI library, so that's Kotlin. The app code, so the application, I also decided to use Kotlin there. I'll explain you why. And for the website, I use Spring Boot and Vaadin because we already use that for drums, the website. I use it for my job. I have used it at my previous job, so it's something I know. So that was simple. I could get started very easily. And for the boring part, I have GitHub Actions and JDeploy. I hate build jobs and setting them up. That's not my job. That's not something I like. So I want to do this very upfront in a project and never think about it anymore. JDeploy helps me there. So that's our architecture. We have 4 GitHub projects. The left one is the distribution. So JDeploy pushes every new version to that public repository so that everyone can download it. As we try to make money out of this, we have a private repository with the application where all the business logic is and the magic. And then we have the views. I will show you at the end. Everyone can contribute or see how the views are generated, because that's what I want to share back to the community is how did we create these views and what can you maybe learn from it. And the website is on the right. It's also a private project with Vaadin and Spring Boot. And GitHub Action is gluing everything together. Now, there are 2 things I want to share which are not really related to the topic of this talk is uberspace.de. I don't know if you know them. It's a very cheap hosting provider where you get for €5 per month, you get a virtual private machine. So you can run, we are running Java on it and a PostgreSQL database. So for €5 per month, that's what we can spend with this project on this website. And as we try to earn money, Polar.sh is also something to keep in mind. If you try to earn money from a project, from GitHub sponsors, for instance. If you want to get money because you're sharing an open source project, take a look at polar.sh, because as soon as you start earning money from something like this, you drive your accountant crazy. Because every country has a different tax system, you need to make invoices. Someone says, yeah, it's not what I wanted to buy, can you refund it? They will take care of it. Of course, they will take a small profit, a small share of your profit, but please keep this in mind. A merchant of record, polar.sh, is one such a company, and they are very open, and it's a pretty new project. They also share a lot of their code open source, but it's something to keep in mind. If you're trying to sell a book, for instance, is also consider this. Now, I mentioned Kotlin a few times. I have to admit I'm that person. I'm that person. I'm a Java champion. I have to use Java. That's not true. I love Java. I love talking about it. Of course, I have to look at other things and what's available there. And actually, I used this project to try out Kotlin. And Kotlin has a few advantages in this project. So it runs on the JVM. It's something I know. Huh? The JVM itself in Java are very stable, so we can make use of that. And you can mix Java and Kotlin, which is a great advantage. I will show you a few examples. And you can write cleaner code, which is very important. And why Kotlin, in my case, is to learn something new, one thing at a time. If you start on a pet project, focus on one thing to learn. Because I already know Java, I know JavaFX, I know to make a GitHub action, I know to make how to make a website with Spring and Vaadin. So Kotlin is the thing I'm learning in this project. I'm not using all the features of Kotlin, it's mainly the language itself. So it runs on the JVM. Who's still running on Java 8 or earlier? I'm sorry for you. We have this cadence of new releases, 2 each year with new features. We can make cleaner code, readable code, maintainable code, and we get a lot of performance improvements. So that's very important, is keeping up with those JVM releases every 6 months. So what I'm using in this application is virtual threads, for instance. Makes my code cleaner, can do stuff that I couldn't do else in another way. Switch expressions, the whole instance of and how things changed, pattern matching. So it makes code so much more readable and easy to maintain, like text blocks is another such improvements. And as I said, with every new release, without changing your own code, if you just bump the runtime, you get better performance and better use of the memory. So it's something to keep in mind. If you're stuck to Java 8, I just written a blog post that it's a ticking time bomb to stick to Java 8. Some people replied, yeah, but you cannot blame me, it's my manager. Then really, really have a good talk with that manager, because there are a lot of reasons to switch. If you want to keep track of what's happening within the evolutions of Java, again, please take a look at listen to the Fujay podcasts. Every 6 months we have a podcast dedicated to what's included in the new release of the JVM. And they are also stable. I talked with a lot of people already today, and something that comes up again and again, we have this very old application, but we bumped the runtime, and it still works, and we have more performance. So Java is boring, and boring is good. You want a boring system. It just needs to work. It's just something you can maintain. You can go into the code and recognize it. It's not something which was written a long time ago in some strange language that you don't recognize. That's what Java is. The Java of today has evolved, but you can still recognize it and just add the new features. I don't think JavaScript systems written 13 years ago will look like that if you open them and run as smooth as Java can do. And you can mix Java and Kotlin, as I said before. So these are the dependencies which are in my application or in our application. I mentioned KT-MIDI already. Atlanta FX is a theme to apply to a JavaFX application. Charts, we're going to show you. FXGL is a game engine, a JavaFX game engine. Yes, you heard it right, which is also included. It's how we create the piano effect with the particles. Java CV is a wrapper around FFmpeg. So it's how we can export what you see on the screen into a video file. JDeploy, I had said it. So there are a lot of things you can mix. So let us show you another non-typical use case of looking at music. These are business charts. How many doughs did you sell this month? So we have all these charts here. And you see again that they are updating the whole time. So this chart library is created by Gerrit Grunwald, who is world famous in the world of JavaFX because he has created many, many libraries and blog posts in the past. And I'm now happy to say he's a colleague at Azul. He's still making this kind of amazing stuff with JavaFX. So what you see here are different types of business charts collecting data from a stream. Sounds familiar? It's again the things we are doing in our day job and listing how many things we sold on the website and how many invoices were created. So it's the things you can do with JavaFX is visualize data in many ways. Again, this is a very basic UI. If I have time, if someone buys this and throws a lot of money to us to make this more fancy, we will definitely do. But you see, you have all these different charts and all these events happening. So it's again just a demo of how easy it is to link data to something you visualize. Is this fancy? Is it useful? I don't know. But I like it. I can just let him play if you want, if it's more interesting. Okay, thank you. Cleaner code. That's also something which you can achieve with Kotlin. And there are pros and cons here. Not everyone agrees with me. But on the left side, you have a Java way of defining a border pane. A border pane is a typical layout of an application with an upper, left, right, center, bottom, and you can put different stuff in there. So in this case, I have a border pane, and on the left side, I have 3 buttons aligned vertically. Completely readable, completely understandable. This is perfect code, Java code. The Kotlin version, you can write it the same way, or you can use an apply block, an apply method there. And then you nest some stuff in each other. I like the right approach. It's how my code becomes a bit more readable. Like on the left side, you have the VBox being repeated 3 times. First you create it and then you apply some methods to it. On the right side, you have everything within the apply block. It's a nice way of it's very readable, definitely for a UI application like this. I have written a blog post which has a lot more examples. So I have the same application, exactly the same application in one Maven project, and you can start either the Java version or the Kotlin version. So you have the same output, but the way it's written is a bit different. Check it out if you want more of this comparison. Now, I already mentioned virtual threads. By the way, this is the last AI image I have. Virtual threads and what can we do with it in Melody Matrix. We will come back to that, but let me first explain it a little bit. So OpenJDK 19 had the first preview feature of virtual thread. Who knows the system of preview and incubator features in Java? Because that's a bit confusing. So, like for instance, virtual threads, you could use them already in Java 19, but you had to, in your IDE, click Enable Preview Features, or you couldn't write the code. And at the runtime side, you also had to -enable preview features, something like that. Otherwise, it wasn't available. So it's a way introduced in the OpenJDK system to get a new feature in OpenJDK, but it's not finished yet. They want feedback, feedback from all of you. That means if you're trying out something and you think, maybe I can use virtual threads and I have Java 19, let's see what I can do with it. So you can try it out and you can give feedback to the developers. And they will, depending on the feedback, do something. In this case, in OpenJDK 20, it was in the second preview. So it meant it was not finished yet. Not everyone was happy with it. There was some feedback. And only in 21, it was finalized. That means from OpenJDK 21, Java 21 on, you could use virtual threads without the extra enable preview features flag. They are lightweight threads, as they call them, and they are managed by the JVM runtime. That means that they don't take a lot of memory, they are just Java objects. And so they have no one-to-one mapping with the OS threads. Let me visualize this. So imagine you have a system which can handle 4 operating system threads. Now your Java application has a task to be done. It gives it to the thread, and it's being handled. At some point, it's waiting for an API call. It's waiting for the database. So it has to wait. But still, it's there. It's blocking your operating system thread. So if you have 4 tasks and 4 threads, no problem. They can be run in parallel, and they will be executed as soon as they are out of their blocking state. Now, if you have a 5th task, it's blocked. That 5th task has to wait until one of the other ones is gone, until it's completely finished. Now, virtual threads is completely different. Now we need some funny music, because there's actually something funny happening. You can create as many threads, virtual threads, as you want. They are just Java objects, taking a little bit of memory, and they are handled. The first 4 are given to the operating system thread, and then at some point one of these tasks is waiting for an API call. It's blocked, it cannot proceed. Then the JVM will say, oh, no problem, you go back to the to-do list, I take the next one. And so on. The next one is finished, it takes the next one. And then suddenly that second task is unblocked, the API answered with something, so it will take that one. And you go on and go on and go on. So until all these tasks are finished. So virtual threads are very small objects which are handled when it's possible to handle them. And they are parked to the side as soon as they get blocked for some reason. Okay. But you have to use them with care, because they are ideal for concurrency, switching between tasks. That's something different than parallel, running tasks in parallel. They are perfect for blocking operations, like waiting for a file, waiting for a database, waiting for an API call. So I/O-bound tasks. They are not for long-running tasks. If you have some heavy CPU task, handling a lot of data, calculating something, it's busy, it's doing something for the whole time, don't make it a virtual thread, because it will actually generate some overload in there, because it gets some extra timing stuff added to it. So it's not for long-running tasks which cannot get blocked. Okay, keep that in mind, because many people thought virtual threads, I will just make everything a virtual thread and my problems are solved. No. There's not such a thing which solves all problems. We know that as developers. The difference in code is very small, and that's why people tend to use it very easily. It's just a thread of virtual, and you have something which becomes a virtual thread. So that's not what you want to achieve. And we have a perfect use case for virtual threads in Multimatrix. Because what is a recording of a MIDI event? So if we are playing music, what is actually happening? We have a start timestamp for a recording. Then we have a note on and a note off, which is a bit harder. Voila, we have a note on, then we have the note off, then we have another note. So we have this whole timeline of events, which are just lines we can save into a JSON file. So this is actually what a recording looks like if we record a MIDI song. So we save it into a JSON file, we have a start timestamp, and for every event which happens, we again have a timestamp and the data. Those 3 bytes we've seen at the beginning, those 3 MIDI bytes. Now, playing this whole recording, playing it back, there's a lot of code here, but there's only one thing which is important here. Every task, every event becomes a MIDI data player. You have it on line 6. And on line 7, we create a virtual thread to handle that task. And what is the task doing? Waiting, sleeping. The only thing that this task has to do is sleep until the data has to be sent to the device. So this is a perfect blocking use case that we can use in virtual threads. Okay, let's try it. So I have this record button here, and we're going to record a small piano piece. So you see every event, every note that he plays or releases becomes a number there. Okay, thank you. Finish. As you can see here, I can send data back to the piano. And I have here a thread counter. So as soon as I hit this play button, all these lines, there are 167 lines in there, becomes a virtual thread. You see the counter going down. Every note that you have my voice again. We also record the audio there. Okay. You see, did you hear a difference between what he originally played and the recording? I think virtual threads can do the same thing. So let's make a new recording and make it a bit longer with a bit more events. And I'll shut up. So now we have 350 lines. Isn't this magic? These are 350 threads. Try this on normal threads, on a normal machine, and see how much smoke comes out of it. Okay? Of course, for the sake of the demo, we also have one with 4,000 threads. So we made a recording with 4,000 lines of JSON data, and we just created 4,000 threads. And you're counting down, so they are executing as soon as they have to execute. By the way, what you're hearing now is a piano, so we're sending back the MIDI data to the piano. Isn't this great, virtual threads? But use them with care. Remember, okay? Now, no, it's not a typo. We have some LEDs here, so let's see what we can do. Some people may know me as the Java on Raspberry Pi guy. I'm that silly person that 5 years ago thought, yeah, I want to learn something new, and let me experiment with electronics on a Raspberry Pi. And because I'm a Java developer, can I do that with Java? Short answer, of course. But it was a bit of a struggle to get started. There was not a lot of documentation at that time. I started writing down my experiments into blog posts, and suddenly I became a book author. So you can, of course, get this book on my website as an ebook. I keep updating it, so I have to start writing the 2025 update soon. So I have all this stuff laying around at my desk and in my drawers. So I have this little board on the right. Who experimented with LED strips before? It's fun, but it's hard because a LED strip needs a very dedicated timing. You have to send the data for each of these LEDs in a very strict timing, in a very strict order. And you can achieve that with microcontrollers, for instance. And this little board has a microcontroller, but you have to send it the data that it has to show through a serial link, which is very old again, a very old standard, and then you can control different things. I created UI again, a very simple UI. For every node I have a color block. And if something happens, the color changes, and I can grab the color again. And what I need to send to the LED strip is a byte array. Very easy data, very simple data. For every LED, I have the RGB, red, green, blue value. It's just a value between 0 and 255, just the same thing you need for web colors. And I can create such a byte array in Java with only a few lines of code. Again, let's see. By the way, did you see my stress just before the talk? It didn't work, so let's see what happens. So this is the UI. Again, some simple data binding. By the way, the data binding between all these components is something which is also done with FXGL, that gaming library. So I can just play here. Now, this is the magic button. Yes! The demo gods are here. So, again, we can play around. And I'm using virtual threads here again, because I have two things going on. I have the UI, which needs to be updated, and I need another thread to grab the colors and send them to the strip. Something happening? Yes. I can also make it a bit different. Again, a totally different way to look at music. How can we visualize music on something like this? Huh? Again, is it useful? I'm not sure. It's fun. And that's very important for our project. You would play on for hours and hours, huh? Thank you. Okay, I mentioned at the beginning, I want this to be a demo project of what can be done with JavaFX. So the views which are in the application is a public project. So you can go to GitHub, get this project, and you can run it separately, and you can contribute. So my goal is that one day people say, yeah, this is a completely different way to look at music, and I implemented it for you. If you want to do that, you're welcome. So let's see how this happens. So what is the test project? It's a project which contains both a Maven and a Gradle config, so you can run it with whatever you want. And you don't need an instrument or recording files, but you have the full code of, for instance, this piano view. And now I have inside this application, I've built Vik into this application because I can play random data. So you see what's happening. So you see it as some kind of unit test or integration test. How does my view look like if you play some music? So you can use the full application here. I changed some stuff. So everything is here, so also the charts. So, but this application, it doesn't communicate with instruments. So you don't hear anything, but it has all the views. And all this code is available on GitHub. It's not rocket science. It's just simple Java and JavaFX and Kotlin. And it shows you how you can use all this kind of stuff. You can even simulate the fastest piano player on the world. Not even Vik can play that fast. And that's where you see the limits of the rendering. Okay. I actually have, when did we start the presentation? 15, so I have 5 more minutes, right? Thank you. Because that's exactly where I wanted to end up. Do you want to contribute? Then there are a few solutions. You can throw us a bag of money. That's one thing you can do. That will make him very happy to achieve the goal of becoming rich. And if you have any other idea or way to contribute, then call us. Yes. Call us and maybe contribute, or if you have an idea of, do you know a way how we can visualize this kind of data, then maybe we try that out and put it in the application. As I said, this is the QR code. This brings you to my website where you can find all the links that were given in this presentation and a bit more. Please rate us. I think that's through the app. I don't know. And if there are any questions, please shoot. Thank you. With the music. Okay. Yeah?
Have you tried, so this is all from a MIDI JSON,
yeah,
or the MIDI standard. Have you tried an audio file to a MIDI? Difficult, but is that something?
That would be very difficult. So what we use as data, so the question is did you use audio file to generate that kind of stuff?
Would it be possible?
It would probably be possible, but I have no idea how to start. I know how to start with the MIDI. That's what we've done. The next step that I want to take is there is a MIDI standard. The MIDI standard also has MIDI files. So if he writes music with MuseScore, which is a well-known tool to write sheet music, you can get a MIDI file. I want to import a MIDI file into Melody Matrix that you can play it back to the piano, for instance. I have a very first version of that already included, thanks to JetGPT, my senior code pair programmer. And because it's JetGPT, it's not perfect and it doesn't work as expected, so I need some work there. But that's the first step we want to do, is really integrate everything which is MIDI. And that's converting audio to a LED effect like you have here. That's something we've done before, which is, you can find a lot of code there, but that's really using the audio spectrum, like you have this audio meter on your hi-fi thing. But going to the sheet and finding the notes, no.
I'm an Ableton user.
Yeah.
With an Ableton, there's actually a way to do that,
yeah,
but it's very flaky.
Yeah.
I was wondering if there's a better way.
Then if Ableton is not able to fix it, then I think to pet programmers, but it's a challenge.
You never know.
Or join the project. You're welcome. Okay, not question.
Yeah, I was wondering what Vik played. Is there some variance in what he played versus what we hear? Because aren't you quite reliant on the scheduler to schedule at the correct time?
I don't hear a difference. There are probably scientific ways to prove this, but it's audio, it's music, and it's as long as you're not a professional musician like me, then you don't hear a difference. Heb je al verschil gehoord tussen wat de computer en wat hij zelf speelt? Nee, nee. He's real. He detects errors I don't detect. So, yeah, I don't think so. There will be a difference, of course. But Java is so capable of going into milliseconds and lower if you don't have garbage collector kicking in, but that's also not an issue anymore with modern garbage collectors, then this shouldn't be an issue. Yeah. But again, challenge accepted to find a way to prove my point here.
I was just wondering, maybe you could take a recording and then overlay.
Yeah. It's a program in progress. You probably heard my voice at some point back. So we also have audio recordings in the application. We also have video recording of the screen. So we definitely have, on the website, we have a list with ideas for the future. So I need to add it. So again, welcome to join and help us in any way. Yeah.
I noticed you didn't use the FXML. Wouldn't that make it easier?
did some of you use Flash in the past, which is the same way to build UIs? I'm from that generation where you had the same thing. You could create an XML structure for your layout and then interact with it from software. It's not my preferred way. But again, it's up to everyone who uses JavaFX. So it's a way that you define your layout in an XML file and you can bind it to methods in your code. If you click a button, finished? Okay. It's a great way in JavaFX, but it's not what I use, but you can do it. Okay, thanks a lot for your time. Now, go have a drink.